Okay, so according to Newton's law of cooling, the rate of the temperature of hot object, so the rate of the temperature, so theta, d theta dt. So the rate always over with t is proportion. So what's meant by proportion? So the rate of changing of your temperature is proportion, your max proportion, the difference between the temperature of the object and room temperature. So given that the temperature of the object is denoted by theta, room temperature is theta naught. So the difference, therefore, the difference is theta minus theta naught. So change this proportion to differential equation. So the first part, write down the differential equation to describe the above situation. So when we change the proportion to mathematical equation, it will be equals to a K constant here. So for cooling system, it will be rate of decreasing. So your constant should be negative. Okay, so your constant here, as you know, temperature when your cooling is from bigger value drop down to smaller value, so rate is negatively, so therefore you have a negative constant here. Then so that will be our first part, write down the differential equation. So b, if denote room temperature is 20, so as we know, when you're doing cooling object, the changing your variable is theta only, room temperature is fixed, this is constant. So for this constant is given in question B, which is 20. We have to solve this differential equation in general form, in general solution. So for part B, we substitute our constant here, which is our room temperature 20. Then we start to solve this dE using separable method. So you can see your variable here is theta and T. So only one factor involving variable theta temperature, T don't have. So we can separate this factor. So factor of theta, we go to the left hand side, which is theta minus 20 d theta. Negative k dt, we go to right hand side. We integrate both sides. So observe this fraction. Denominator here is a linear, therefore we can straight away get ln theta minus 20. And then coefficient of theta is 1, so over 1. So seems like it doesn't have any big effect here. We just straight away using ln theta minus 20. So for right hand side, integrate respect to t. It will be negative kt plus c. Then we have to simplify until general solution. So general solution means theta as a subject. Then theta equals to something. So simplify this, unlock this ln. Remaining theta minus 20, it will be e to the power of everything here. Then we separate the EC, multiply with EC. When you have power of plus, means your base will be in multiply. So base E multiply base E, power of kt, power of c. So this E is constant, c also constant. We can simplify, denoted it as a. So lastly, theta equals to a e negative kt plus 20, general solution. So observe our equation here. Theta is your variable, t is your variable, a is a constant, k is a constant. So if you want to find your particular solution, means you need to find out your a, you need to find out your k. So for this question B, we just stop at general solution. Then for question C, you can see they give you more information coming in. So what's your story timeline? Based on your variable here. So based on your variable here, our variables is time and data. So the object takes 15 minutes to cool down from 115 to 75. Means start from initially 115. Then after 15 minutes, you reach 75. Find the time taken for object to cool down from 75 to 30. So what's the time taken here? So based on the data that we have here, we substitute. For question C, we're going to substitute initial value, which is T0, temperature 115 degree into general solution here. So T0 times K, everything becomes 0. So e power 0 times e power 0 is 1. So 115 equals to A plus 20. A 115 minus 20. 95. Continue another information to obtain K. So substitute data equals to 75 where T equals to 15 minutes. Substitute our A 95, E negative K that we want to find, T is 15. So slowly we move back minus 20, 55. Then we remove the coefficient here, divide by 95. 55 divided by 95. 11 over 19. So when we move back E to the left hand side, it will become ln. So negative 15K. So lastly, K is divided by negative 15 for ln 11 over 19. So finally, particular solution. So E negative K, so negative K, negative, negative become positive. T plus 20. Particular solution. So lastly, answer the questions when they want data equals to 30. What is the T? Alright, so substitute into our particular solution here. 30, 95, E 1 over 15, then ln 11 over 19 times T that we don't know, plus 20. So again, we simplify one by one. Move the 20 here, so we get 10. Then move 95 coefficient over 95. Then we move the ln together, we simplify with 10 over 95, 2 over 19. So finally, to get T, we divide the coefficient. So we move this, it will be going to ln 2 over 19, divide the whole coefficient of T. So 61.79 minutes. Alright, so read from the story here. Actually, start from beginning. After 15 minutes, it will be cool down to 75. Then after 61.79 minutes, it will cool down to 30. But the questions asked here is time taken cool down from 75 to 30. So from 15 minutes to 61 minutes, what is the time difference here? So the time taken to cool from 75 to 30 will be equals to so of course the decimal here a bit difference from the answer because when I use K I use the whole function here. I didn't do any rounding, so I won't have any rounding error at the ending here. So it takes 46. So you have to be careful. The understanding here when you look at the story timeline here means everything refer to the initial. After 61 minutes, it comes to 30. So if you want in between, we have to minus. What's the starting referring to 75 Celsius here? The starting here already over 15 minutes.